Welcome to this webinar in the Pilsen INSPIRE hackathon series. We are delighted to have you here. And with me, I have three excellent experts that you will learn a lot from. My name is Bente Lilja Bye. I'm going to be your host, and I'm also going to introduce you bit by bit about the INSPIRE hackathon itself and how you can participate. But today, first, we will learn a lot about what data that are available for all of us, open data related to climate and agriculture. That's the theme of the day. And we will also learn about some examples and so on. In order to get everybody on board and give some time for everybody to attend, I have this trademark when I host webinars that we do a weather report first. And I'm excited today, and you will learn very shortly why. But we will start with you, Julia. Can you give us a very brief weather report and tell you where this weather is?
Yes, I'm based in Rome. Good afternoon to everyone. And yeah, in Rome, it's sunny, very nice and pleasant after the heat in August. So it's a very nice autumn sunny day.
Oh, sounds lovely. And Karel, where are you and what's the weather like?
Hello, I'm in Pilsen, and the weather like here is, the IT experts usually don't look through the window, but my cell phone says that it's 19 degrees of Celsius and semi-cloudy.
Yes, and here comes my delight today is that Cristoph will be very professionally be able to give us a weather forecast. Won't you, Cristoph?
Well, I can look out of the window, and in The Hague, it's raining. After a really hot summer and long periods of no rain, the rain has finally arrived, the rain that we are used to here.
Right. But the reason why I said that is that your profession is to provide us with weather forecasts.
That's correct.
Yes.
I won't do it now, but yeah, Meteo Blue operates a weather forecasting service and also has a big archive of simulated weather data, and you'll see some of that a bit later.
Exactly, that was my teaser. We will learn more about weather forecast, or specifically a specific type of weather forecast. I will also tell you what the weather is like where I am. And I'm in Norway, just outside Oslo, in the forest outside Oslo. And today we have sort of a beginning of an autumn weather, overcast with some rain every now and then. So the autumn is definitely here. If you want to tell us what the weather is like where you are, we would appreciate that. It's always fun to discuss weather. So, before I start and give the floor to Julia, but Julia will introduce us. I would like to do some more housekeeping because you are able to ask questions directly to the speakers now. This is one of the benefits of attending a live webinar. So don't hesitate to ask questions also in the chat box. We will be able to answer these questions. Some of them might be natural to take up directly after the presentation, but we will also have a Q&A session at the end of the webinar. So don't be shy, ask us questions along the webinar as you hear what the speakers have to say. With that, I give the floor to you, Julia, that will introduce us to the vast amount of data related to climate that we have here in Europe. The floor is yours. And say a few words about your background before you start. Thank you.
Okay, thank you, Bente. Okay, yes, good afternoon, everyone. I'm very happy to be part of this webinar today. My name is Julia Wagemann. I'm currently doing a PhD at the University of Marburg, but I'm also a visiting scientist at the European Center for Medium-Range Weather Forecasts. And for the last 4 years, I've been working in the intersection between a data provider, which is ECMWF, and also data users trying or making the large volumes of open data we have available, making them better accessible to data users. And yeah, this is why Bente asked me to give you a short overview of what data is available from ECMWF and is part of the Copernicus program, which I will present you today shortly. And for this, I will just turn on my my presentation, and I will turn off my camera.
Yes, and so will we, but you will see us again later, all of us. But we will turn off the cameras while Julia is presenting.
All right. Okay. So as I said, I've been working, before I started a PhD, I've been working at the European Center for Medium Range Weather Forecasts. For those who don't know the center, it is based, the headquarters is based in Reading, and we are primarily a numerical weather prediction center, providing weather forecasts to national meteorological services. But we also operate two of the Copernicus services, the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. And due to these Copernicus services, we have a large amounts of meteorological and climate data specifically available, openly available, and ready for users to use. And I want just to give you a short overview what kind of data is available. And the most popular data set is the ERA 5 reanalysis data set. It's data going back until 1979 and providing climate information to almost near real-time data. And the data will soon also going back until 1950. And it has a temporal resolution of hourly. It has an hourly temporal resolution and a spatial resolution of 30 kilometers. And we have also a subset of the ERA 5 reanalysis data, which just covers the land parts of the globe. And this even has a better spatial resolution of 9 kilometers. And additional to the climate data, which is going back to 1979 at the moment, we also provide seasonal forecast data. And there we provide monthly forecasts up to 6 months ahead with a spatial resolution of 10 kilometers. But we not only have data on climate, we also have data on air quality. And here we also have reanalysis data spanning the time period from 2003 to 2016. And the data has a spatial resolution of 80 kilometers. And we also provide air quality forecasts on a 3-hourly basis up to 5 days in advance. And the air quality data are parameters on ozone, carbon monoxide, sulfur, nitrogen dioxide, etc. But not only on air quality and climate data, we also have data on fire danger. And here we specifically provide indices on fire danger. So the possibility that a fire might occur. So we have a range of fire danger indices, for example, fire weather index, fine fuel moisture code, DAF moisture code. And the data is available for a period from 1980 to end of 2018 with a temporal resolution, with a daily temporal resolution and a spatial resolution of 80 kilometers. And last but not least, we have data like on flood, specifically on river discharge information. And here we have forecast data on a 30-day period. So data going back from 2018 to almost real time. And it has a daily temporal resolution and a 10-kilometer spatial resolution. So this is the forecast data, but here we also have a reanalysis data set where we have like a time period of almost 30 years spanning from 1981 to 2017. So these are the open data sets available. And as I already said, the good news is because it is available on the Copernicus full, free and open data policy. And because I understand like the hackathon participants interested in data and you want to use them, I want to give you a short example how the data can be retrieved, because we talk about of large volumes of data. So like, for example, one parameter of the ERA 5 reanalysis data set, the hourly parameters is around 700 gigabytes. So we have some Python and R libraries, which makes it easier to access and download the data. And then also with Python, there's a range of Python libraries, which is easier to handle the data. So the data is mostly in grep or in netcdf data format available. And in Python, there's the CDS API. And you can download it, you can install it, and then with Python, you can, in a programmatic way, you can download the data. And the good thing is that if you go to the Climate Data Store website, I will show you in the next slide some resources where you can also see some links where to access, and it makes it easier for you to find the data. And if you go to the Climate Data Store and you select some data, for example, 2 meter air temperature or total precipitation, you can, right at the end, you can let you show the CDS API retrieve request. And this is here an example of the CDS retrieve request. If we're interested, for example, in 2 meter air temperature, then we can select a specific day or even a range of days or a range of months. And we can specify the area, because this might be of interest, because meteorological data are per default on a grid going from 0 to 360 degrees. And if we want to have it on a regular latitude, longitude grid, we have to specify the area, basically saying that we want to shift the longitude values by minus 180 degrees. And then we can also specify the time. This is an example to retrieve hourly data, but there is also the data already available on a monthly aggregated basis. So if you're just interested in the monthly data, then it makes much more sense just to download the monthly aggregated values. And yeah, so with the CDS API, you can download the data in either grep or netcdf format. If you want to have the netcdf data, then you have to specifically specify netcdf as the format. Per default, you will retrieve the data in grep. Once you have downloaded the data, then there's a range of Python libraries available which make your life much easier to handle the data. And one of the game changers is the Xarray Python library, because it makes it very easy to load the data in netcdf and grep, and also to load multi-dimensional data in netcdf and grep. And once you loaded the data, because the library has been developed to make it easier to make it easier to work with climate and meteorological data. There's a range of functions and methods available to make it very easy to aggregate data, to resample data, etc. But as well, there's also another library available, netcdf4, which also makes it very easy to read netcdf4 data, and then you can store the data and the data values in a NumPy array if you're more familiar with NumPy arrays in Python. For the R community, there is at the moment there has been a package developed to download as well the data directly from the CDS, from the Climate Data Store, and the package is the ECMWF R package. So with this package, you can easily also download the data. And once you downloaded the data in R, you can use the raster package to load netcdf files. And then there are also a range of functions available to aggregate and resample raster images. And this is just some resources to make it easier for you to find data and to get access, just where to find and where you can download the data. So there's the Climate Data Store, where you find all the data, all the climate data and seasonal forecast data related to the Copernicus climate change service. You can also have a look to ECMWF public data sets if you're specifically interested, for example, in the air quality data, but we also have an additional range of open public data sets you might be interested in. If you're interested in the flood data, you can go to the globalfloods.eu, the global flood awareness system, and the fire danger forecast data is available on Zenodo. We also have a range of open data available as part of a web mapping service. And if you're interested in retrieving these map data, then you can access our web mapping service endpoint under this link. And I just gave you, as an additional resource, I would like to point you to example notebooks I've developed as part of a workshop earlier this year. So if you want to see how you can work with X-array and load the data, for example, or how you can set up your retrieve request, or if you in general just want to get some more information about how the data is structured, I welcome you or invite you to go to have a look at these notebooks because you get some more background information. And with this, I would like to conclude my short presentation, but please let me know if you have any other questions. And I hope that you will make use of some of the open data available from ECMWF. Thank you.
Thank you so much, Julia. That was so helpful and should be of great use for those who are participating in the Pilsen INSPIRE hackathon for sure. Can you unshare your screen again, please?
Yes.
So we have a question here actually from Cristoph. And I was going to say that all of these slides will be shared to the community. You will either get it via your registration here, so you will get an email with those slides, and we will post them on planforall.eu. So planforall.eu. You will see that Karel already posted a link to a description of the Pilsen INSPIRE hackathon already, so you can start with that to read more about the Pilsen hackathon. But that's where on planforall.eu, that's where you will for sure get a copy of this presentations in PDF form. So thank you very much, Julia. If you have questions to Julia now about these data sets, both more details, or if there are any other types of questions, while we are waiting for you to type this in the chat, I actually have a question, or maybe two for you, Julia. And that is, these, we are discussing climate and agriculture, and you were mentioning air quality and fire forecasts and flooding forecast. Now, just since I grew up on the countryside and actually have a farm, I can relate to this. I can relate to the link between these types of data and agriculture, but maybe that's not usual. Do you have any, maybe it's not so known to those who didn't grow up in the countryside. Do you have any examples on how they are being used for climatic research connected to agriculture?
Well, like the climate data, like for example, ERA 5 data, we have information on 2-meter air temperature, also total precipitation. Precipitation is like one of the driving factors for agriculture, right? So, this is also getting a problem because in more and more parts of the world, we get less and less precipitation. So this is a very valuable information or data source that can be used to study and monitor specifically also agricultural applications. To me, like temperature, the same, like if we get like heat waves or heat periods, it's influencing or affecting agriculture. Then also flooding forecasts, of course, is very helpful. This is probably also the linkage with precipitation. If we can better forecast flood periods, then we might be able to better prepare. But still, for agriculture, I think it's good to know what's going to happen, and specifically if we have flood periods. But it's often it can be disastrous for the agricultural fields, right? If we have a flood, because it's really hard to prepare or to change something in the field or in the field settings. I think there's like a lot of linkages between the data, and what we always say is like the beauty or the importance is that the open data, different sources of open data are combined, because we have to understand the entire system, all the factors that actually affect the space. So I really encourage everyone to also combine different data sets.
Yes, exactly. And I have a little, I like this to put on fire the grass in the spring. And I also know that we also, the farmers in the old days here in Norway, they were, burning the aftermath after they harvested. Now, I think we see this is actually still going on in the Amazon. We have all heard about the fires in the Amazon, but there are fires all over the place in Africa, in Russia. There are big fires. Now, if it's very dry, this is where, this data for the fire forecast comes in. If you are using this method in agriculture, it's really very good to know exactly how dry it is. What is the likelihood of a fire? Because then you should ideally not use this method of farming, right? This is just to mention the climatic data and farming as one example that maybe many people can relate to just now. Yes, now I think I don't see any other questions here. So don't be shy, still chances to ask questions, and we will take that to Julia also in the Q&A. But now I think we are ready for you, Cristoph. Can you give us a short introduction to who you are, and then let us know all about Meteo Blue? Thank you.
Yeah. Thank you, and thank you for the opportunity to present here and show a little bit about Meteo Blue. We are here because we are also participating in the Oikstad project, as Karel does, where we, number one, supply some data, but more importantly, learn how our data could be used better and could be made better available, and how it would feed into processes in agriculture and so on. At the end, I may say a little bit more to the commercial model. Suffice to say, what I'm showing you now as examples and so on, all of that is available for the hackathon, and in fact for the duration of the Oikstad project, to freely experiment with. And should we find boundaries, then, and if you experiment and you get messages such as a number of calls exceeded or so, then please do let us know, and we'll adjust those boundaries. We put them somewhere in the middle right now, so we have a way of monitoring the level of interest. Okay, but we are more than happy to make these boundaries wider. Okay, then I'll stop sharing my camera and show my screen instead. Oh, maybe one or two words to myself.
Yes.
I'm actually a geologist by training. So between the moderator and myself, we span basically the universe because she's an astrophysicist. But in geology, I was number one. I was always interested in meteorology as well. I'm a glider pilot as a hobby, and I'm very interested in quantitative methods. And at some level, whether you do fluid flow through a reservoir, or whether you do the flow of air in the air, of course, there are vastly different processes, but some of the principles are the same. Specifically, the principle is that all models are wrong, but some models are useful. One has to just know how and to use them. And I hope to give you a little bit a sense of how Meteor Blue goes about this problem.
Excellent.
Okay, so let me share my screen, which for some reason.
Maybe I have to do it like this. Yeah.
Yeah, is this? I have to say I tried it once before and then escaped out of it. So I hope this hasn't upset the system. If it has, then I will go out and connect right away and ask Bente to do some bridging remarks. And I'm afraid I have to do that. So
okay,
I'll
okay,
be back in
Cristoph, no problem.
Right?
Yeah. See you soon. So while he is getting back to us, I don't see any more questions. Don't be shy, as I said. Please go ahead. I'll let you see me. So we can go back to, so Julia really helped us now to with some guidance on actually to access the data. That is actually some of the problems that we discuss in group of Earth observation. And one of the problems that we in Plan for All are really concerned with, that's one of the reasons why we are organizing all these INSPIRE hackathons. So this slides that Julia just gave us, those are of great value, I can tell you that. So make sure that you look for the PDFs when you get it. Now it looks like
yes,
Cristoph is on his way in. Yes, welcome back.
Is it okay to share my screen now?
Go ahead.
Okay, so this is the Meteor Blue website, and I set it to Pilsen. There is on our website for free available is a lot of information. I mean, this is as a weather resource, really free weather resource, second to none, I would say. And we can have a quick look at the 2-week weather. Of course, a 2-week forecast is very uncertain, as you can see here. But if you go to Pilsen on Monday and Tuesday, right now it looks as if sunshine should be fine and it should be dry. I mean, there's no rain between now and then. But you see up here a little bar, and that actually tells you how confident Meteor Blue is in the weather forecast. At the end, I'm going to talk a little bit about how we actually do that. For now, just see that actually we are very certain for today, less certain for the next 3 days, and then quite certain again until after 5 days, it really starts deteriorating. You can also see this in the uncertainty bands here. So it's not just that for 1 or 2 days it's certain and then it becomes uncertain. There are certain weather conditions that are harder to predict than others. And then the predictability goes down, reflected in these bars. Okay, but let's go to the talk. I want to show you a few examples of the API that you can use in the hackathon. There's actually an API key that is open for the duration of the OICSAT project. And I want to show you briefly some elements of the website, how you can produce maps on demand. To specifically for agriculture, give you an example of some ready-made diagrams that you can get, but then also show you how you can access data and also historic data. And in the end, I'll go back and talk a little bit about the forecast quality and how MeteoBlue actually, what the data is that that you can access through MeteoBlue. And at the very end, just in the slide set, are a couple of examples for Pilsen that you can then try out for yourselves. So you can, on the MeteoBlue website, and I'm going to do it right there, generate some map that's interesting to you, and then immediately use a key or an API call to get that particular map to yourself. So you can already see that what MeteoBlue does internally, and where the maps and so on are produced from, is exactly the same API that you would be using in order to include weather information in your application. So you see under the settings down here, you can switch on or off this developer info. And if you have switched it on, you just get the API call to experiment with. It does have, as an API key, just a token text, and that you would have to replace with the API key that is in the slide set and that I showed you before. To change what you want to look at, that's satellite and pressure, that's temperature. Those are all the things that are configured for the website, so that the visitors to our website can look at that. And you can see that actually our coverage is worldwide. And obviously, depending on whether you look at world coverage or whether you're looking at the area around Pilsen, you will get different resolutions of the data, and the models that these data are drawn from will have different resolutions. As you have heard before, if you have a question for clarification and so on, please fire away. Just to show you, if I just take this and copy that, and I'll put it in here. It's actually exactly the same thing because I tried it out before. You see, you get this overlay where areas without information are just left translucent. So you see the background through that. That's quite helpful if you want to stick it onto a web map. You can get then little things that give you interesting information about a particular location. This here is basically, I think this is done for, I have to look at, oh yeah, this is actually for Nairobi in Kenya. And this is the time zone is Zurich. But I know it's Nairobi, Kenya, because I prepared it for another talk. And I can see that obviously in the lat and long. So they're going to have typical tropical weather for the week, low and high temperatures, winds, precipitation, the UV index. And the rain spot is actually quite nice because it shows you the rain pattern around your location in a 30-kilometer radius. So again, typical tropical, there are showers around the place, less shower.
Cristoph, did we lose you?
It seems like Cristoph is disconnected now. We still see his screen, but no
The
voice.
sound disappeared. Maybe you pushed the button by accident, Cristoph? if you hear
Maybe
us.
I did.
Yes.
I can
Okay.
hear you now.
Yes.
Let me try to come back. I may have to do the same spiel as just a minute ago in order to share my screen again.
Oh, the screen is all. It's okay. The
You
screen
see
is
my
there.
screen? Okay, very
Yes.
good.
Yes. The
Okay,
voice
because I
isn't there.
cannot see it anymore on
Oh,
my.
yourself. Oh,
Okay,
okay.
good. But if you see it, that's enough. I just cannot see the feedback. I cannot see the view that you see. I see the four. Right now, I see the four speaker pictures.
Yeah, that came to us as well. So you can reshare it, perhaps.
Yeah. Okay. Let me see. I'm trying to. Yeah. My apologies. Your moderating skills are required once more. I'll come back.
Yes. Yes. No worries. This is technology. We all know that this can happen. So we will wait for Christoph again. And I'm sure I personally, I find it very interesting to look at these weather forecasts that we can then gather information from. I don't know about you guys, Julia and Karel, if you are avid users of weather forecast. I'm looking at the weather forecast several times a day, maybe because the weather is changing so much where I live. Maybe Rome is less required to check the weather. It's sunny all the time. What do you think, Julia?
Well, I think it's better than in other parts of the world. But still, it's like if I've been working for a weather forecasting center, so I should have an interest in weather forecast.
Yes, more than average. Yes. Yeah, that's of course true. But we just learned from Karel, he doesn't even look at out of the window.
Yes, yeah, true.
So, yeah.
We are actually
So
forced by Meteo Blue to use just their application for forecast in the project. So
yeah, so there
I
is
could
no
say
other.
stuff, but he is coming back hopefully.
It looks promising. Yes.
Yeah.
Are you with
Hello,
us,
I'm back.
Christoph?
Yeah,
Yeah, good. Okay. The floor is yours again. Go ahead.
thank you.
We will turn off our cameras and
Yeah,
mics and give it to you.
yeah, thank you. So, typical tropical situation. If you had rain coming through, like a front, you could actually during the day see how the forecast in the rain spot shows the band of rain going through. Now, this is a meteogram which is done specifically put together with parameters that are of interest for agriculture. So, for example, you have a prediction on evapotranspiration, so just how much liquid is going to be lost through leaves. And this here is a spray window, so it gives you a color code for when, based on the weather condition, it may be a good or not so good idea to actually spray your crop, or there are other versions that tell you about fertilization and so on. But it's a quite complex diagram, and it is pre-packaged and available through a simple call here. And those are the calls that you can experiment with in the hackathon. So very similar for sowing. And for sowing, of course, the precipitation is interesting. So the precipitation is shown up here. And then the sowing windows for different crops and sowing recommendations are being given. Here's a spray window in detail and precipitation and temperature in detail. So here's the full advice. Here is just the base data for it. This is an interesting one because it says something about, can you go with machinery onto the field or not? And in order to make that prediction, we predict soil moisture. Ideally, that would be calibrated by a sensor, but if you don't have that available, what you can do is you have sort of a low water mark and a high water mark. So when it has been dry for a long time, you know that the soil is going to be completely unsaturated. And if it has rained for a long time, you know that the soil is completely saturated. And you can just do a little bit of accounting for additional water that comes into the system to do an estimate of soil moisture. For many applications, that would not be sufficient. It may also be not very accurate at all times, but it is a useful indication. And if we can combine it with actually soil moisture data taken from a sensor, then we can, of course, refine the calibration and make this forecast more reliable. We have already seen an example for 14 days. So you can see that Basel is wetter, at least for now, for the next few days than Pilsen. And that the predictability over the next few days is actually pretty bad for Basel, although it was quite good for Pilsen. Okay, so that is just interesting information to have when you want to use the weather forecast within certain bounds of uncertainty, and take advantage of knowing whether or not this is certain or not certain. There's also seasonal forecasts, but be warned, they are very experimental, and we know how difficult it is from the press. I mean, there have been famous cases where the Met Office in the UK has ventured a seasonal forecast, and it turned out to be almost exactly the opposite of what they forecast. But this is not that they don't know what they're doing. This is just the difficulty of making long-term forecasts. Now, a lot of the API calls will actually return data. And you saw examples from Copernicus where you could very finely specify what data we are interested in. MeteorBlue in this classic API has predefined packages that will then return to you whatever the package contains, and you can control for when you want it and for where you want it. But the number of parameters is somewhat limited because they are all encoded in the URL string. We are having a more advanced interface where you can post a small JSON document that looks similar to the signature that we saw for Copernicus a minute ago, but that is still under development. If you find you want to do more and have to have finer control than what these examples give you, let me know and we can look into this. Here, this is one particular output where we actually show multiple models together. You see, here are 1, 2, 3, 4, 5, 6, 7, 8, 9 models together. You see the temperatures that they predict, the rain patterns that they predict, the sort of weather situation, the wind speed and wind directions. And this can be quite useful because you may be interested, while the forecast is uncertain, you may be interested in early morning on Friday. And actually, early morning on Friday, most of the models agree. There's one with a little bit of rain, but most of the models agree. So you might actually trust that the rain will not be too bad. Going into the multimodal a little bit more, so you see the coverage that we have. Quite a large number of models from 2 families on different domains are operated by MeteorBlue. And then we take publicly available models. In addition to that, we put everything together and evaluate that as a multi-model ensemble. And that's how we can make extract information about the predictability, because we just say if all the models agree, then it's highly predictable. If they all diverge, it's not very predictable. And we actually have a learning scheme that takes into account real data and compares it with the predicted data from all the models and learns over time to, given the location and given the weather pattern, to automatically select the best model or to come up with the best forecast. And we do that successfully for 3 parameters right now: temperature, dew point, and wind. And we are working on more parameters. But those of you who are a bit familiar with machine learning will probably appreciate that in machine learning, it's not that one size fits all. The underlying problem in the case of weather forecast, it's the physics of weather and obviously also the availability of data and the physics of a particular variable that you are looking at that require, number one, to look at a different mix of correlations and also to apply different learning strategies in order to actually be successful at learning. So a large number of domains, quite a variety of resolutions, but you can see that, for example, in Southeast Asia, we have 18 kilometers. Global, we have 30 kilometers everywhere. There is Japan in East Asia in 8 kilometers. That reflects a little bit where our business is, because running these models, of course, incurs a cost. So we do a number of them where they are needed anyway and where we need them. And then certain customers may want additional domains, and we do those. And then here you see what's available publicly that we are using. So and that's available for free for a service like ours. That's a German model that runs Europe at 7 kilometers and globally at 13 kilometers, which is quite good. ECMWF is very good, but we would have to pay for it. And so far, we haven't had anybody who wanted that quality or the additional value that it can bring and would have been prepared to pay for it. You see, there we are a bit different from Copernicus. We are a private company and we have to make the numbers work for us. I won't go into too much detail here, but I want to point out that we do quite a bit of verification, validation of our models, and we actually publish that. So if you dig a little bit around our website, or if you follow this link here, you will find these verifications. Here, for your convenience, I have added one slide where, for example, it should be possible to just go there, and you see this is the query. The city is Pilsen. The time zone is Prague. It's selected the closest one with lat long, the API key that you can also use. Metadata about where the data is from, and then actually the hourly data for various variables. And this here is the field, I believe, that has to do with a rain spot. Yeah. see there's a rain spot and the pattern for the rain spot. And you see it's very dry in Pilsen over the next couple of days. I hope I didn't. I probably lost my. Here, let me allow me to find this again where we are. So there's also additional technical information for the API, including a file that you can download if you really want to get your hands dirty, as it were, and try out various things. There is a lot of useful additional information if you want to add certain parameters or if you want to understand how to exactly change them around. Okay, that's the end of my presentation.
Okay, thank you very much, Cristoph. That was very interesting indeed. So if you have questions to Cristoph now, don't hesitate, ask directly in the chat box. I will ask my speakers if you have a question to Cristoph on the fly. No questions, but I have. I have questions. I really enjoyed all the details, and indeed, so your weather forecast is tailored to agricultural applications, right? The most important data when you ask agricultural sector or the farmers, what is the most valuable data for them, Earth observations, it's the weather related data. And what you are doing is to provide products, aggregated products that are specifically tailored to those who are actually farming, right?
I did show you that element, but to point out the packaging for agriculture is very specific. It combines the parameters that are interesting for agriculture. We have others. I mentioned before in our chat before the session, we have one that is actually quite popular with a very small community. We can tell how well you can see the stars. And there is a phenomenon. If you have a clear sky and you see the stars, on some days they will appear to shimmer, and you call it seeing. You say that the stars are seeing, indicating this apparent movement. And that has to do with density contrasts within the atmosphere. So if you want to take a picture with a long exposure and you want a sharp image of a star, then you want to have minimal seeing, and that means there should be, other than no clouds, which is obvious, there should also be a stable layering of the atmosphere. There should be no strong winds in the upper atmosphere. And so we provide this prediction, and astronomers take that to plan their nights out, because if you have to go in winter a night out with all your equipment only to see, oh, there's a jet stream overhead, then so we can spare you that trip.
Yeah. The scintillation of stars is not necessarily, that's pretty to look at, but not so useful when you're taking pictures. But I want, so obviously you can use what you are tailoring to agriculture can actually be applied to other fields as well, which is why we have an Earth observation community, to have this cross fertilization we call. Not everybody likes that, but to me, that's one example. But we are talking about climate and agriculture. Now, weather forecast, the weather is different from climate. So how long time series do you have? I mean, how long have you been modeling the data? Is it something beyond 30 years or?
Yeah, so of course the rule of thumb is weather over 30 years is climate, if it's at least 30 years. The company was founded in 2006. But what we are doing is actually, since the historic initializations for weather models are available, we are using the modern models to recompute old forecasts. And we do that all the time in the background, as it were. And we are now in the area of 1984, where we have, for different parts of the world, historic weather forecasts. And what we do, we store the forecast of it's between 12 and 24 hours. Basically, the forecast from the day before, because we have found that is the best estimate for the actual weather on the day. And of course, it will be not as good as having a historic record at a weather station. But as you move away from weather stations, or as you go to areas where there's no weather station at all, the forecast is the best estimate, and we compare that to ERA 5. We use ERA 5 as well, and we love the Copernicus as a really valuable resource. Since we can do additional processing, it's not only analysis, we also apply some of the things that we have found from our multimodal ensembles. And we can actually, in certain parameters, we can actually, at verification sites, get a little bit better than ERA 5. So whether it's enough to actually, our data costs something and ERA 5 is free, whether it's worth the difference, we are in the process of finding out. Again, for people who are interested in machine learning, the historic simulations are, of course, an excellent training data set. And all machine learning algorithms, if the models are biased, which they are all, will learn the bias of the model. So if you then take that in order to apply what you learned from your training data sets in the actual forecasts, it's a big advantage if the forecast model is the same that was used to generate your training data. So as that, the full package data back from 1984 and from now 2 weeks out is actually quite useful to have.
Yeah, and thank you for that. That was a nice segue for Karel, because now we are going to switch over to be very practical. How can we use this information? And so what you describe now is more detailed climatic data on a specific day, on a specific location. And I think, Karel, that is something that you are talking about in your example. So I will give the floor to you now, Karel. Please, thank you so much, Cristoph. Karel, you will introduce us to an example on how to use both information, data, and models, and other information. Can you introduce yourself very quickly, and then let us learn about a very interesting example?
Hello, everyone. Thank you, Bente, for the introduction. My professional background is geomatics, geographic information systems, and in this case, I would speak about multi-dimensional data analysis, where time is one dimension and the geographic patterns are the other dimensions there. I'm originally from the University of West Bohemia, and here in the project I'm on behalf of a Wireless Info Association. So that's a bit about me, and now I will switch to my presentation. Just a short question, Bente, to you: how much time do I have for
the presentation?
For my presentation?
Yeah, I feel I have been a bad moderator because I have let you spend more time than anticipated. But we are on the hour, so if you can do this in 10 minutes, that would be great. And then we have 5 minutes discussions afterwards, or something like that, for you in the audience. So we are going to be. I didn't say how long time we expected in the beginning, but we tend to try to use an hour. But let's say 1 hour and 15 minutes now. Okay, Karel, go ahead.
Okay, thanks. I will speak about an example, as was mentioned, of leveraging climatic data in agriculture. This is an experience in the EUSTAT project. This was already mentioned by Cristoph.
Sorry, can you turn off your camera as well before?
Okay, so
Yes.
yeah, I didn't did that. Sorry. Okay, so I will turn off the camera and come back with the presentation. Is it fine now? Okay. So the agro-climatic zones. This is something I will come to a picture which defines the area based on some climatic characteristic. It could be temperature. It could be raining in the area, etc. But usually these kind of maps are very generic. Just to show you, this is the last freezing day in Canada zones. You can see other zoning in Brazil. This example is, I think, from India. And here is another example from the Sri Lanka. What I want to show in these pictures is that the size of the zones are very different and usually a bit generic. So what we want to achieve with using climatic data, both from Copernicus services or MeteoBlue data, is to define these agro-climatic zones a bit more detailed than they are used to be in past or even today. So that's the goal. And let's say when we have the zoning, for example, for temperatures, we can answer, or maybe not just temperatures, but I will use this as an example. You can answer some of these questions which are here at the slide in front of you. I will now focus on the first one. Well, let's say I'm a farmer. It's 1st of April, and I would like to know which of my fields are safe to operate, safe to start seeding, because I don't expect freezing anymore in the field. So what I can do is actually find an environment where I can search for climatic data and get that information for which 1st April in last 30 years it wasn't freezing in which field. Of course, if I have one field, that's not the case, but if I'm part of a bigger farm, then it makes sense to pick up fields which are safe to operate and to postpone operation on the fields which aren't safe for that particular date. So where I can calculate such a thing, well, of course, I can have some desktop software. Speaking about the EUSTAT project, there is a cloud-based architecture which could be used for that. I will show that later. So what I would like to do in this very straightforward example is to request temperature data basically for all 1st Aprils in last 30 years, for example, and search for each particular place with the grid we have available. So we have learned that the grid size could be different, but let's say 4 to 4 kilometers using MeteoBlue data. And we can count if there was temperature above or below 0. Well, just short notice about the factors which are influencing the temperature. The biggest factor is elevation, and we can see other factors as well: distance from water source, orientation of slope, land cover, etc. There are more or less topography related factors, and you can see also the influence to the temperature. Elevation is the most important, most influent factor. So I will take a look at the elevation a bit closer. We all know that the temperature usually is related to something which is called 2 meters above the ground, which is kind of a tricky because you don't know what's the ground. It's usually a very sparse model. You have heard that 4 to 4 kilometers is very fine resolution, but for the topography, it could be very very coarse because the topography differs much more. So keep this in mind, and keep this in mind also the rule that the temperature usually decreases under normal circumstances by 0.65 Celsius for each 100 meters of elevation. So now, knowing this, this is an example of a coarse model where the elevation from in the climatic model is related to. If you take another model, yes, you can see here the profile as well. You take another model, more granular one, and you compare two places, for example here, of these two grids, and you can see that you can easily get the difference in these 2 meters above ground definition of temperatures in this valley, for example. So this is what we wanted to change in the model. So what we did when we modeled the elevation factor was that we take the elevation on the surface. Sorry for the small numbers here, but then we apply the recalculation of temperatures at sea level. Just to mention the rule I mentioned, we know it could be more complex than I mentioned, but for the simplicity, we use the 0.65 Celsius. It could be changed in the model anyway. So we go to the sea level here. We interpolate to a more dense grid using, in this case, EU digital elevation model, which is 30 to 30 meters resolution, so it's much more dense. It's maybe even more dense than is necessary for the meteo data, but we did it for example. Of course, it could be a bit coarser, like 100 to 100 meters or something like this. But we did the interpolation at the sea level because at that moment we have off the terrain influence to the temperature, or the topography influence to the temperature, and then we used the more detailed EUDEM model to interpolate back to the surface, and you can see if you compare these two temperature fields, you get just a bit different information. And for example, in this area, it could be a game changer because you have the information in more detail than before. Actually, where we did it, it's the EUXDAT platform of giving us the Jupyter notebooks connected to grass functions, GIS grass functions, to other tools as well, and last but not least to both data sources, to MetaBlue data and to the Copernicus data as well. If I take a look to the core of the code here, you can see the calculation of temperatures at the zero level, interpolation of these temperatures, and recalculation back to digital elevation model. You can see that GIS grass functions are used here. So far, we did it just for 1 year, and then we can iterate it for the years we are interested in. Of course, this step could be easily parallelized if you want it for more days or for more hours even. So there is an opportunity to parallelize the process. But of course, now we have kind of a simulation. We saw a video of what we got from the weather service, and what we interpolated to a higher resolution. We can also get some kind of a synthetic output, like information about days which were above zero, which were below zero and above zero. Different types of maps could be portrayed from the data then, and this could be the basis for the agro-climatic zones map, for example. Well, that was one example. I will just shortly comment another example. It was for a hackathon in Nairobi. We were searching for days which were above 35 degrees of Celsius. Let's say if we see such kind of areas in July, which is there a start of seeding season or could be start of seeding season, then you can expect problems in these areas because it's too high temperatures and too drought. And using this 28 to 28 kilometers cells, which are I think we used CDS data for that. You can see that you would expect kind of 6-7 days maximum of the heat here. But if you use the decreasing space, increasing the spatial resolution, you now can see that the difference is, or the whole picture is different. You can see that there are areas which for sure are facing high temperatures almost the whole month. So in this case, the size matters, and the smaller is the better. Well, I show you, let's say, two examples of geographically and time-related questions which could be answered using the data we were talking about them this webinar. We can find more complex questions which we are working on as well, but it's not that easy to explain it in 10 minutes. But what all of these questions have in common is that you usually need some data, meteorological data, topographic data, for some reason also land cover data. Then you can pre-code something which can be of use of a final user, like in this case algorithms applying some corrections to temperatures. We were talking about the elevation. We have prepared something also for hydrology, slope orientation, and land cover. And this is something, this is the base, the E infrastructure, which a user can use and do a specific analysis, like for specified place and time period, get the temperature rasters densified, and then do the analysis of freezing, hot days, changes of climate in history, suitability for crop types, or whatever else. So this is, I would say, the interface in between what's prepared in the EUXDAT and what's then for the user to play with the data and to get the answer to his or her questions. So that's all from me now. Thank you for attention, and I'm ready for your questions.
Thank you very much, Karel. Indeed, there's a great potential of using this climatic data for agriculture. I think we are all convinced about that. I have a very specific, so again, do ask questions in the chat. We will probably continue for a couple of hours. No, sorry, not a couple of hours, a couple of minutes. But you mentioned, there's a lot of details there, of course, but you mentioned, and this might be useful for those who are actually going to use this information that you got. You showed an example of some code on the EUXDAT platform. And can you tell us where we can find a Python notebook for the coding environment for those who are interested in coding? I mean, that might be interesting to know.
Yeah, thank you for the question. The environment is actually a bit experimental still. You saw probably the test EUX.eu site, but one thing is if you contact us at the EUX.eu project site, or you can write me an email directly, and we can give you the access to the environment. And I think that in the future it will be some information about how to access it directly from the website, but it's not we are not that far yet. But it's planned for sure.
Yeah, and thank you, because now you just gave me a very good reason for those of you who are watching these webinars. You are developers or students, or you are diving into actually using the data. And the INSPIRE hackathon concept is actually to create this continuous activities in hackathon. So it's not so much as a competition. We will have some fun with the competition of it, of course, but it is more to create this group where we all share the same interest in using our open data, combine it even with commercial data, as was presented by Cristoph. But all together, we want to learn from each other and create this community over a longer period. That's what the INSPIRE hackathon's about. And in interest of time now, I just want to use the opportunity to point you to the chat box where Karel provided you with a link to more information about the Pilsen INSPIRE hackathon. It's going on now. Just go there and register and use the information you got from these experts today. And there will be another webinar tomorrow where you can get more information and more inspiration. But now you are going to be hacking virtually. So you can use Skype and, Zoom or whatever tools that we are using these days on the internet to work in teams on specific problems that you're interested in. It could be more on the application side. You can interact with some farmers, or you can dive deep into analysis and reanalysis of the wonderful data that we have accessible. It's up to you. Then we will meet. We organize sort of the finale and the ending of this Pilsen INSPIRE hackathon in Pilsen, obviously. Where you can enjoy some very good beer. I'm a testimonial to that. And you can also continue to hack together if you have the opportunity to go to lovely Czech. Please do that, and you can meet. Otherwise, you can also participate remotely to Pilsen. Isn't that right, Karel? You are in Pilsen and have been organizing.
Exactly right.
Yeah. So it's the 23rd and the 24th of September. That's when you have the finale. And we will have some sort of fun ceremony on where we present the results of the hackathon. So that's, I wanted to make sure that you got this invitation. I hope you learned a lot from our presenters today. I certainly did. And yes, and tomorrow we have a new webinar at the same time at 2:00. You heard about several APIs today, and tomorrow we will be introduced to even more APIs. We have the Open Search API on the Next.js platform. We have, what else do we have? We have the Mundi platform that will be presented, and then we have the Agricultural Digital Innovation Hub, where you also can play with APIs and other tools. That's for tomorrow at 2:00. With that, you should be ready to dive into the Pilsen INSPIRE hackathon. But before we say goodbye now, I would like to give the floor to each of the speakers. And Julia, do you have any final comments or encouragement for us today?
Yes, enjoy hacking. And I'm really excited already about the results that are coming out.
Excellent. And Cristoph?
Yeah, I second Julia. And please, if you get stuck somewhere, there's an email address in the error messages that come. Use it, and we'll try to help you.
Excellent. Good opportunities for combination of open data and commercial data here, which is an interesting case. And Karel, a final word?
Well, I think everything was said, so come to Pilsen.
Yes. Yes, absolutely. Thank you so much, guys. Thank you so much in the audience sticking with us here. You will get the replay in directly in your email since you register. And you will find the presentations on the Plan for All website for sure very shortly. Thank you so much, and bye-bye for now.
Thank you. Bye.
Bye.